This is our second video solving right triangle applications. These applications are going to involve angles of elevation and angles of depression. An angle of elevation of an object seen by an observer is the angle between the horizontal and the line of sight from the observer's eyes to the object. The object in this instance is going to be above the observer's eyes. The angle of depression of an object seen by an observer is the angle between the horizontal and the line of sight from the observer's eye to the object. In this instance, the object is below the observer's eyes. So basically, if you check out our diagram here on the side, if your normal sight, if you're just looking straight ahead, your line of sight is this horizontal line. If something is above you and you look up, tilt your head up, to see it, this amount that you tilt your head up to see it is the angle of elevation. Now, if there's something that's below your natural sight line and you look down to see the object, this amount that you look down from your normal sight line is the angle of depression. So, amount you look up, angle of elevation, amount you're looking down, angle of depression. To measure the height of Lincoln's caricature on Mount Rushmore, two sightings 800 feet from the base of the mountain are taken. If the angle of elevation to the bottom of Lincoln's face is 32 degrees, and the angle of elevation to the top is 35 degrees, what is the height of Lincoln's face? We'll round our answer to the nearest hundredth. Well, with any application, I'm always going to start with a diagram. So we've got Lincoln's face on the side of a mountain here, and we're trying to figure out how tall his face is. So two sightings are taken from the base of the mountain. Well, I'm going to come like straight down his face to get the base of the mountain. And our sightings are being taken 800 feet away. The angle of elevation to the bottom of Lincoln's face is 32 degrees. And then the angle of elevation to the top is 35 degrees. And we want to figure out how big his face is. So we kind of have to come up with a plan on how we could use this information to help us find the size of his face. Well, if we find the height of the bigger triangle, I'll call that Y, and then we find the height of the smaller triangle, call that X. If we find these two heights and then subtract them, it will give us this amount right here, which is the height of Lincoln's face. So that's our overarching plan. The face is going to be equal to Y minus X. And now we just need to find each of those values. I'm going to draw two separate breakout triangles so we can work them individually and then put the ideas together. So I'll do the big triangle first. 800 feet away. Our angle of elevation is 35, and we're looking to find this height y. From our angle of 35 degrees, y is the opposite side, 800 is the adjacent side. We use tangent to relate opposite and adjacent sides. So we have that tangent of 35 degrees is equal to y over 800. We can solve for y by multiplying both sides by 800. And that gives us y equals 800 times tangent of 35 degrees. I don't want to plug this in my calculator right now because I really don't want a rounded answer to start working with, and subtract and then round again. So I'm going to keep this exact answer. Now let's do the other breakout triangle. The height is x, the bottom is 800, and the angle of elevation is 32 degrees. From our angle of 32 degrees, x is the opposite side, 800 is the adjacent side. Again, we are using tangent. We get that tangent of 32 degrees is equal to x over 800. Solving for x, we'll again multiply both sides by 800. And we get x to be equal to 800 times tangent of 32 degrees. We established early on that our face height is going to be equal to y minus x. So substituting those in, we're going to have 800 times tangent of 35 degrees minus 800 times tangent of 32 degrees. And I want you to put this all in your calculator all at one time. Frequently in trig, it is easier to plug the whole thing in rather than doing just little pieces. Otherwise, you're going to be rounding and rounding and rounding, and we do not want that. Our final answer, we're rounding to the nearest hundredth. I'm getting 60.27, and our unit is feet. It's one of my favorite examples. All right, let's try another one. The length of the shadow of a building that is 34.09 meters tall is 37.62 meters. Find the angle of depression of the sun. We'll round our answer to the nearest hundredth. So the sun's up in the sky, looking down at the earth, right? So it always has an angle of depression. Anytime they're talking about the sun shining down, there's a shadow being cast, it's always angle of depression of the sun. So here's our sun. And I know it's like ridiculous to say that the sun has a normal sight line, but that's what we're going to do. So if the normal sight line for the sun is here, and it's looking down on Earth, here, this is going to be our angle of depression. All right, so we have a building that is casting a shadow. So this building, I want to put it up here. So like here's our building. I know the sun isn't exactly where the building is. It's up in the sky, but it's looking down and it's casting the same angle. So we have our building that is 34.09 meters tall, and it's casting a shadow that is 37.62 meters long. And we want to find the sun's angle of depression. Well, the thing is that the angle of depression is here. It's not inside my right triangle. So let me point something out to you. We use this geometry property frequently in trigonometry. This sight line of the sun is a horizontal line, and the ground is a horizontal line. So we have two parallel lines cut by a transversal, the angle that the sun is coming down. And we know when you have two parallel lines cut by a transversal that alternate interior angles are congruent. So our angle of depression has the same measure as this angle down here. So what we need to do is simply find this angle, I'll call it theta, inside our triangle. I'll draw a breakout. So we're looking for theta, knowing that this is 34.09 and our bottom side is 37.62. From our angle theta, we have the opposite side and the adjacent side. So once again, we'll be using tangent. Tangent of theta equals 34.09 over 37.62. We're finding an angle. Anytime we're finding an angle, we're using an inverse trig function. So we'll have that theta is equal to tan inverse of 34.09 over 37.62. And we're just going to pop that into our calculator, making sure that we're still in degree mode. We get our angle theta to be equal to 42.18 degrees. And that is the angle of depression of the sun.